Okay, so in the previous video we stopped at testing out what's happening in the app itself. So if I press start, it starts from a 0. I can pause it, I can reset it. There are still a few things that are missing, like if I press start then pause, then pressing pause again does nothing. Whereas if I press start again, it starts from a 0. So it doesn't continue from the paused time. And additionally, our measurement, the time measurement of milliseconds is completely wrong. So let's now, in this second part of this app, fix all these issues. So first of all, the counter is not properly counting time units. Seconds and other time measurements are off. So even though we have a working stopwatch, the time measurement is incorrect. And that's the first thing that I'm going to deal with. Why do we have issues with the time counter? The obvious culprit is this method right here. We're delaying the execution of the start stopwatch method by 1 millisecond. In other words, we're calling the start stopwatch method 1000 times each second. It's quite likely that we're experiencing some lag here, and that's the reason why our counter is off. Even without going into the specific reasons why this is happening, the fact that we're making 60,000 method calls a minute should definitely be cause for concern and refactoring. Then why did we do it like this in the first place? Well, sometimes it's as useful to see an example of what not to do as much as it's useful to see the right way of doing things. This is one such case. So let's revisit the logic of our stopwatch and find a way to make it work better. Going back to the logic of our stopwatch app, we start our JS with this piece of code right here. This is where we set up the variables we'll be using throughout our app. Nothing extraordinary here. Now let's have a look at the 4 methods. Start stopwatch, reset, start it, and pause it. We can see that the start stopwatch is actually sort of redundant here, as we can write it as an anonymous function and pass it as the first parameter to the setInterval method inside the startIt function. The reset just clears the interval, resets the value of milliseconds, and updates the DOM output to all zeros. The startIt itself is just a setInterval setup. The pauseIt simply clears the interval. So to begin our updates, let's save the improved app as follows. I'll update the startIt now so that the interval is a call to Windows setInterval. And then here I'm going to get rid of the start stopwatch, and instead I'll pass in an anonymous function where I'll set milliseconds ++, and I'll set stopwatch .inner HTML to what I have right here. Okay. Next, I'll get rid of the start stopwatch function completely. So now I'll move up the startIt function so that it's sort of logically at the very top here. Then I have the pauseIt, because I'm basically trying to follow logically what is happening on the screen. And finally, the reset is going to have milliseconds set to 0 and stopwatch inner HTML completely reset. So when I save this, it should work as before. But before I even test that, let me further simplify the code by rewriting the startIt method as follows. So instead of this function right here, I'm going to have an arrow function. And this arrow function is just some further simplification. Okay, so all of these updates are really, really basic, and we know exactly what is happening. So there's not really much need to explain it further. The question now is, how do I achieve more accuracy for my stopwatch? And generally, how do I improve the performance of it? A solution would be to simply increase the interval delay, thus lowering the number of the times that the anonymous function gets deferred and then gets pushed back onto the call stack. So instead of doing this each 1 millisecond, I'll do it every 100 millisecond, and I pretty much increase the performance by 100 times, 100-fold. So now that I saved this, let me confirm that everything is still running correctly, or at least as good as it was running in the previous version of my app. So if I press start, it counts like this. Pause now doesn't work, and reset does work, but the start function just keeps on running. Okay, so there are a few things that I need to update to make this code behave. First of all, I'm going to have to update milliseconds to +=100. And I'm also going to have to complete the interval variable name correctly. And now my stopwatch is finally working more or less precisely and correctly. So if I press start, it starts from a 0. Pausing stops it. Pressing start again continues from where it was. I can pause it again, press reset to completely set everything to zeros, and press the start again so everything works. So it's a pretty decent implementation, save for the issue with the formatting of numbers on my clock display right here. But it's pretty good and relatively interesting implementation of a stopwatch. Now, instead of dealing with the formatting here, I'm not going to finish the app as it is currently, and instead I'm going to build it using a different approach, and that's using the built-in date object and calculating the difference between their instances. So to do that, I'm going to borrow some ideas of the code that I have so far, but I'll also introduce additional functionalities. So first, let me start by adding a timestamp at the start of my stopwatch. So basically right here, I'm going to do let start date equals new date. And I'm just going to console.log start date. And I'll also add a date whenever the user presses the pause button. So right here inside the pause, I'm going to add this code right here. Let pause date equals new date and console log pause date. Control S to save, and obviously I'd like to show the difference between the start date and the pause date values. To do that, I'm going to have to declare the start date and pause date variables outside the started and paused methods, so as to be able to both update the variables inside these methods and calculate the difference in values. Effectively, I'm keeping the variables in global scope on purpose to be able to calculate the time difference. So that means that I'm going to have to move the declaration of start date and the pause date right here. And now I can just update the start date variable, not assign it, not declare it, and also update the pause date variable instead of declaring it. So if I now press the start button and wait for 20 seconds, and then follow it up with a press on the pause button, I'd get the following output in the DOM. Of course, I'm not going to wait 20 seconds, but let's wait some 5 seconds, 5.4 to be precise. And now, at the same time, the output in the console is going to be the following. I started at 18 seconds and stopped at 24. So it's a close enough approximation of what is happening here. And I'm happy with it because I can confirm that this thing works more or less to what I've expected. But that also means that I'm off by about some minor amount of time, and that's tolerable because my app is precise down to 100 milliseconds. It cannot count the time in chunks that are smaller than that, so that's still fine. But since this video is getting a bit longer, I'm going to stop it right here, and in part 3 of this video, I'll be incorporating the data updates in the interval.